Hi, welcome to Last Day on Earth. Tell me, where are you listening from tonight, and what time is it for you? Beneath our feet is a hidden fire, a molten core that shields us, moves our continents, and keeps Earth alive. But what if that fire cooled down? What if the planet's heartbeat stopped? Tonight we'll explore how the fading of Earth's core would change the sky above us, the oceans around us, and life itself. Chapter 1. Stardust. When we think about. Would we think about what makes Earth alive? Most of us look upward to the skies. The sun, the clouds, the thin blue layer of atmosphere that protects us. But the true engine of our planet doesn't lie above. It lies far beneath our feet, in a place none of us will ever see directly. Deep down, thousands of kilometers below the ground, Earth has a beating heart. Not of flesh and blood, but of molten metal. It's a core that churns, spins, and radiates heat, and without it, nothing about the world as we know it would be the same. Tonight, let's imagine something unthinkable. What if that heart stopped? What if Earth's core cooled down? The Earth's core is a strange and almost alien place. It begins about 2,900 kilometers beneath the surface, at the boundary where solid rock gives way to a vast ocean of liquid metal. This molten outer core is made mostly of iron and nickel, searingly hot, between 4,000 and 6,000 degrees Celsius, hotter than the surface of the sun. Below that lies the inner core, a solid sphere of iron, compressed by pressure so intense that even such unimaginable heat cannot melt it. This core doesn't just sit idly in the center of the planet. It moves, it convects, it spins, and as it does, it drives the geodynamo, a vast, invisible generator that creates Earth's magnetic field, the shield that has protected life for billions of years. We almost never think about it, because it's hidden. We live on the cool skin of the planet, on solid ground that feels stable and eternal. But that stability is an illusion. Every mountain, every ocean, every volcano exists only because of the restless energy flowing from the core. That energy pushes the tectonic plates across the surface, raises continents, tears open mid-ocean ridges, and fuels volcanic eruptions that renew the crust. It circulates heat through the mantle, creating convection currents that move landmasses like rafts. In short, the reason Earth is geologically alive is because its core is hot. Now imagine the opposite. Imagine if that heat began to die away. Imagine the slow fading of the inner fire. At first you might not notice anything. The core cools so slowly that for millions of years life would continue. Seasons would change, tides would rise and fall, and the world would seem the same. But deep inside, the churning currents of molten metal would weaken. The convective engine that drives the magnetic field would sputter and slow, and in time, Earth's shield would falter. The magnetic field is invisible, but it is essential. Without it, we would be exposed directly to the solar wind, a constant stream of charged particles blasting from the sun at hundreds of kilometers per second. Right now, those particles are deflected, wrapped around the planet by invisible magnetic lines that stretch into space. This is what makes auroras dance in the sky near the poles, a visible reminder of the shield at work. But without the core's heat, without its dynamo, that shield collapses. The auroras would no longer be beautiful lights. They would be the burn marks of a planet unprotected. Think of what that means for life. Our atmosphere, the very air we breathe, is partly held in place by the magnetic field deflecting solar winds. Mars is the cautionary tale. Billions of years ago, Mars may have had a thick atmosphere and flowing water. But when its small core cooled and its dynamo died, the solar wind stripped its atmosphere away. The rivers dried, the oceans evaporated, and Mars became the cold desert we see today. Earth without its magnetic field would face the same danger, not overnight, but slowly, inevitably. The upper layers of the atmosphere would erode into space. The air would thin, radiation would increase, the surface would become harsher and harsher for living things. And that is just the beginning. Cooling of the core would also still the restless geology of the planet. Right now, we live on a world of earthquakes and volcanoes. Dangerous, but also vital. They recycle carbon, release gases that replenish the atmosphere, and build the land itself. If the core cooled, the mantle's convection would slow and eventually freeze. The plates would stop drifting. Continents would lock in place. Volcanoes would fall silent. At first glance, that might sound peaceful. No earthquakes, no eruptions, no disasters from within. But it would also mean no renewal, no recycling, no fresh crust to build mountains or islands. The planet would grow geologically dead, like the moon, its surface frozen in time. Climate too would be reshaped. Without the heat flow from below, the oceans would lose part of the circulation that drives currents. Deep sea hydrothermal vents, places where superheated water gushes from the ocean floor, would vanish. These vents are not just curiosities. They are cradles of life, home to ecosystems that survive without sunlight. Some scientists believe life itself may have begun in such places, and the rich chemistry around hydrothermal vents. With the core's energy gone, those ecosystems would die, and the deep sea would become emptier, colder, and still. On the surface, the loss of the magnetic shield would make radiation a daily hazard. Every walk outside would expose us to higher levels of cosmic rays. Skin cancer, genetic damage, radiation sickness, all would increase. Technology would suffer too. Our power grids, satellites, and communication systems rely on the protection of the magnetic field. Without it, solar storms would fry circuits, disable satellites, and plunge entire regions into blackouts. A single solar flare today can disrupt communications even with the shield intact. Without it, entire systems could collapse. The bigger picture is even starker. Earth's core is not just a heat source. It is the heartbeat of a living planet. When that heartbeat stops, Earth doesn't die instantly, but it begins a long, slow decline. Over millions of years, life would grow harder, climates harsher, and ecosystems thinner. The Earth would become quieter, less dynamic, and more vulnerable. Eventually, stripped of its shield and its renewal, Earth would resemble Mars more than the thriving blue world we know. So tonight, as you sit here thinking about the unseen depths beneath your feet, consider this: our world is alive because of its hidden fire. It is a reminder of how fragile even the most solid things can be. We walk on what feels like permanent ground, but that ground is alive only because of a restless core we never see. If it ever stopped, if Earth's core ever cooled down, the story of life on this planet would be rewritten, not in a day, not in a year, but across the deep canvas of geological time. A slow unraveling of the conditions that make us possible. And yet, it is also strangely comforting, because Earth's core will not cool tomorrow, or in our lifetimes, or even in the lifetime of our species. It will take billions of years for that heart to fade completely. The end is unimaginably far away, but the thought experiment teaches us something profound, that what lies beneath us is as important as what shines above us. The sun gives us warmth, but the Earth's core gives us a shield, a surface, a home. Both together make this planet what it is. Remove Acer, and the balance is broken. So what if Earth's core cooled down? It would mean a planet without a heartbeat, a planet stripped of its shield, a planet growing quiet, cold, and still. It would mean the slow death of a world. But until then, every step we take is carried by a living Earth, warmed from within, protected by an invisible shield born of fire and iron. That hidden heart so far below our feet is the reason we are here at all. Chapter 2. A flicker fading. If you imagine Earth's core as a giant furnace, you have to picture what would happen if that furnace began to lose its fire. The truth is, all heat sources eventually fade. Stars burn through their fuel. Fires on the surface burn themselves out. Even the nuclear reactions inside a reactor cool if they are not sustained. And the Earth's core, despite its staggering size and heat, is no exception. it too is slowly cooling. Not in a way we feel day to day, not in a way that affects our lives over human history, but in the slow rhythm of billions of years. Still, the thought of that fire flickering out stirs a kind of unease, because when the inside of Earth grows quiet, the outside cannot stay the same. Scientists believe Earth formed about 4.5 billion years ago. In its earliest days, it was a world of fire. Planetesimals, the small building blocks of planets, collided and merged, and each impact released enormous amounts of energy. That energy, combined with the radioactive decay of elements like uranium and thorium, created a molten ball of rock and metal. Over time, the heavy iron sank to the center, forming the core, while lighter elements floated above to form the mantle and crust. This separation, called differentiation, released even more heat. The young Earth glowed with internal energy, and it has been radiating that energy outward ever since. But radiating means losing. Every year, Earth leaks its inner heat into space. Some of that heat escapes through volcanic eruptions, geysers, and hot springs. Most seeps upward slowly through the mantle and crust, rising as infrared radiation into the cold void. The loss is small on human timescales, but steady. Like a campfire that shrinks over hours, the Earth's inner fire is dwindling over billions of years. The solidification of the inner core is proof. It wasn't always solid. Long ago, the inner core was entirely liquid. But as the planet cools, more of that liquid freezes into a growing iron crystal at the very center. That process continues today, 1 millimeter at a time, as if the planet is slowly turning its own heart to stone. If the trend continues, and it must, the churning in the outer core will weaken. Convection requires heat differences. Hotter, lighter material rises, cooler, denser material sinks. This movement is what generates the dynamo effect that powers Earth's magnetic field. Without enough heat, the circulation slows. If it slows enough, the magnetic field falters. Earth would not lose its magnetism all at once, but piece by piece. First, the field might weaken, exposing us to more cosmic rays. Auroras would grow brighter and more frequent, no longer confined to the poles but visible at lower latitudes. It might seem beautiful at first, a sky alive with shimmering curtains of light, but beauty would hide danger, because those lights mark places where solar particles are slipping through. They would be the warning signs of a shield losing strength. Meanwhile, the mantle above the core would also change. Right now, mantle convection drives the motion of tectonic plates. We think of continents as fixed, but they are adrift on a slow-moving sea of rock, carried by currents, rising from deep within the planet. That slow drift is why mountains rise, why earthquakes happen, why volcanoes erupt. It is why the face of Earth has never been static. But if the core cooled enough, those currents would stall. The mantle would grow rigid. The plates would freeze in position. Earth's restless crust would finally grow still. It might sound like the end of chaos, but it would also be the end of renewal. Erosion would grind mountains down, but no new ones would rise. Oceans would widen or close, no more. The planet would become geologically quiet, locked in a slow decay. The fading core would also reshape climate in subtle but significant ways. Right now, volcanic eruptions release carbon dioxide, sulfur, and water vapor into the air, gases that influence climate cycles. Without eruptions, those natural contributions would stop. The carbon cycle, which balances the greenhouse gases in our atmosphere, would shift. Eventually, Earth might become less buffered against changes, less stable in temperature over long timescales. Combined with a weaker magnetosphere, our world would be increasingly vulnerable to external forces like solar output changes or asteroid impacts. Think of Mars again. Mars once had rivers, lakes, maybe even oceans. It had an atmosphere thick enough to keep water liquid on its surface. But Mars is smaller than Earth. Its core cooled more quickly, and when its dynamo died, its magnetic shield collapsed. The solar wind stripped away much of its air. The rivers dried into canyons. The ocean basins became empty deserts. Today, Mars is a silent world with scars of a more active past. In a way, it's a vision of Earth's far future, a world where the inner fire has faded to embers. But here's something important. Earth's cooling is not just doom. It has also been the engine of change. The gradual cooling of the planet over billions of years has shaped its history. As the inner core solidified, the magnetic field strengthened, offering better protection to life. As heat escaped, the crust cracked and shifted, creating continents. That very instability may have been necessary for life to emerge. The dynamic planet beneath our feet is not just a stage for life, it is a participant in it. Without the flicker of fire deep below, the story of life might never have begun. And so when we ask, what if Earth's core cooled down, we are really asking about a world that would slowly lose its dynamism. Not overnight, not in our lifetime, but across spans of time so long they are almost beyond imagination. The fading would be gradual, like a candle burning down. 1,000 generations might pass before anyone noticed, but the ultimate destination would be the same. A planet quieter, colder, less shielded, and less alive. This thought experiment reveals something humbling. We like to think of ourselves as masters of technology, able to build, adapt, and protect ourselves. But all of our ingenuity depends on a foundation we cannot control. Our shield in space, our moving continents, our oceans and atmosphere. All of these exist because the furnace inside the planet still burns. We do not fuel it. We do not tend it. It simply exists, a legacy of Earth's violent birth, a gift of radioactive decay, a balance of forces we can only measure and imagine. And someday, far beyond our reach, it will fade. So as we picture the Earth's core cooling, let's not only imagine the doom of a fading shield or frozen crust, let's also imagine the wonder that it still burns at all. After billions of years, the heart of Earth still beats strongly enough to protect us, to shape continents, to sustain oceans. It still flickers with the energy of creation. The cooling has already begun, but the story is not ending yet. In fact, in human time, it is only just beginning. The fading of the core is the faint ticking of a clock so vast we cannot hear it. Yet it is there, steady and slow, reminding us that nothing, even the heart of a planet, lasts forever. Chapter 3. The magnetic shield breaks. When you step outside on a clear night and look up at the stars, it feels calm, almost eternal. The sky is quiet, the moon glows, and the faint shimmer of stars reminds us of how small we are. But that calm is deceptive. Space is not empty silence. It is full of energy, streams of radiation, particles hurled from the sun, cosmic rays arriving from distant galaxies. The reason we don't feel this chaos directly is because Earth has a shield. It is invisible, powerful, and taken for granted. It is our magnetic field, and this shield exists only because the core is still hot, still moving, still alive. If the core cooled down, the shield would falter, and with it, the fragile protection that makes Earth habitable would begin to crumble. The magnetic field of Earth is created by the geodynamo, a self-sustaining generator driven by the liquid iron in the outer core. As this molten metal churns and swirls, it sets up electric currents. Those currents in turn create magnetic fields, which reinforce the motion, keeping the cycle alive. It is one of the grandest natural machines in the universe, a hidden dynamo deep beneath our feet. The result is a magnetic bubble around the planet, stretching tens of thousands of kilometers into space. We live entirely inside that bubble. Without it, life on the surface would be exposed. The first sign of a weakening shield would not be silence, but light. Auroras, the northern and southern lights, are already the visible signature of our magnetic field at work. Charged particles from the sun spiral down magnetic field lines near the poles, colliding with molecules of nitrogen and oxygen in the atmosphere. These collisions release energy as shimmering curtains of green, red, and violet light. Today, auroras are confined mostly to high latitudes, but if the magnetic field weakened, the auroras would spread. They would appear closer to the equator, glowing above cities that have never seen them. At first it would seem like a gift, a sky filled with luminous storms of color, but it would also be a warning, because those lights mark where radiation is getting through. Radiation is not something we can ignore. The solar wind is a constant blast of particles traveling at hundreds of kilometers per second. When it strikes Earth's magnetic field, most of it is deflected. But when the shield weakens, more particles push through. They collide with the atmosphere, eroding it atom by atom. Over thousands of years, this erosion adds up. Mars shows us the result. Without a magnetic shield, Mars lost most of its atmosphere. Its rivers dried, its climate froze, and its once thick air thinned into a tenuous veil. Earth without its magnetic field would face the same fate, though at a slower pace. The upper atmosphere would be stripped away, molecules of oxygen and hydrogen carried off into space. The planet's ability to hold onto its air would diminish. The consequences for life would be harsh. On the surface, more cosmic rays would strike. These high-energy particles can penetrate deep into living tissue, damaging DNA. Cancer rates would rise. Mutations would become more frequent. For some organisms, this might drive faster evolution, but for most, it would simply increase the risk of extinction. Radiation-sensitive life, like plankton near the ocean surface, could decline, disrupting the base of the food chain. Agriculture would be harder. Outdoor living would be riskier. Humans might be forced to build more underground shelters or radiation-proof structures just to live safely under the sun. Technology, too, would suffer. Our satellites orbit within the magnetosphere. They rely on its protection to shield them from solar storms. Without it, satellites would be fried by high-energy particles. Communication networks would fail. GPS would become unreliable. The International Space Station and any spacecraft in orbit would face a dangerous increase in radiation exposure. Astronauts would be vulnerable to doses far beyond safe levels. Even on the ground, our power grids would face new risks. Solar storms induce currents in long power lines, and without a strong shield, those storms would be more frequent and more intense. Blackouts could stretch across countries, crippling modern society. But perhaps the most unsettling change would be in our sense of safety. We live on Earth as though it is permanent and stable. We build cities, raise families, and write histories under the assumption that the world will always provide the same shelter. The magnetic field is invisible, so we rarely think about it. But if it weakened, we would begin to notice. We would notice it in brighter auroras, in more frequent blackouts, in satellites that fail, in higher rates of illness. Slowly, the realization would spread the planet's defenses are failing. And unlike a wall we could rebuild, or a roof we could repair, this shield is beyond our reach. It exists because of the churning liquid iron far below us. If that motion stops, we cannot restart it. This is why scientists are so fascinated with Earth's magnetic history. The record of ancient rocks shows that the field has reversed many times, north and south flipping places. These reversals suggest the dynamo is not perfectly stable. Sometimes it weakens, sometimes it strengthens. Right now, the field is weaker than average, and some geophysicists wonder if we are heading toward another reversal. If that happens, it will not mean the end of the field altogether, but it reminds us that the shield is not guaranteed. It is a living system tied to the flow of heat inside the Earth. And when that heat dies, so will the field. We do not need to panic. The cooling of Earth's core is a process that takes billions of years. Long before the shield collapses completely, humanity will have either adapted in extraordinary ways or moved beyond this planet altogether. But as a thought experiment, it sharpens our perspective. It reminds us that Earth is not a static object. It is alive, dynamic, fragile in ways we cannot see. Its shield is not a given. It is a consequence of fire, motion, and chance. So what if the Earth's core cooled down and the magnetic shield broke? It would mean living under a sky that glows with warning lights. It would mean breathing air that thins century by century. It would mean adapting to a world where radiation seeps into everything, where the sun's wind bites instead of caresses. It would mean learning that the protection we always assumed was eternal was in fact temporary. a chapter in Earth's story that will one day close. And yet, even as we imagine this, we realize how lucky we are. For now, the shield still holds. For now, the auroras are still gifts of beauty, not warnings of danger. For now, the invisible bubble stretches around us, letting us live in comfort without ever thinking of the chaos outside. It is easy to take such things for granted, but when you look at the night sky again, remember the calm you feel is an illusion. It exists because of a shield that is fragile, invisible, and utterly dependent on the fire deep inside the earth. A shield that one day will break. Chapter 4. A quieting planet. For as long as Earth has existed, it has been restless. The ground beneath us is never truly still, even when it feels solid and eternal. Every continent drifts. Every ocean basin shifts. Volcanoes rise, mountains crumble, earthquakes ripple across fault lines. It is the hum of a living planet, the soundless vibration of a world that has not yet grown old. And all of it is powered by the heat rising from Earth's core. But what happens when that heat begins to fade? The planet does not just cool, it quiets. The chaos we fear, eruptions, quakes, and shifting plates, would disappear. At first, it might sound like a gift, but the stillness of a planet is not peace. It is death. Earthquakes are terrifying, but they are also proof of motion. They happen because tectonic plates grind against one another, driven by convection currents in the mantle. These plates, huge slabs of lithosphere, move only a few centimeters a year. That pace feels insignificant to us, but it is the force behind continents colliding, oceans opening, mountain ranges lifting skyward. The Himalayas, for example, exist because India continues to press into Asia, lifted by the energy still pulsing from the Earth's interior. Without that inner fire, the convection would stall. The plates would lock in place. Earthquakes would vanish. The Himalayas would stop climbing. The world's crust would freeze into its final shape. No longer a moving puzzle, but a completed picture. Volcanoes, too, would fall silent. Right now, the molten heat from below creates pressure that eventually bursts through the surface. Lava pours out. Ash rises, and gases escape into the atmosphere. It can be destructive in the moment, but it is also essential. Volcanoes recycle carbon and water between Earth's crust, atmosphere, and mantle. They are part of the planet's breathing system. Without them, the cycle of carbon would be broken. Greenhouse gases would no longer be replenished from within. Over long stretches of time, the balance of our atmosphere would tilt. The air might grow thinner in carbon dioxide, which plants need for photosynthesis, weakening entire ecosystems, or the atmosphere might become unstable in other ways, since the natural rhythm of volcanic release would be gone. A silent Earth would not just be quieter, it would be less balanced. The oceans would feel the change as well. Right now, hydrothermal vents dot the ocean floor. These are places where seawater seeps deep into cracks, heats up near magma chambers, and gushes back into the sea loaded with minerals. Entire ecosystems thrive around these vents, living without sunlight. Some scientists believe life on Earth may have begun in such places, but without a hot core, the heat source vanishes. The vents go cold. Those ecosystems die, leaving the deep oceans darker and emptier. More than that, the circulation of heat between the interior and the seas would weaken, affecting global ocean currents. The conveyor belts that carry warm water across the planet, shaping climates, driving weather, would slow. The climate would not stop changing, but it would shift in new, unpredictable ways. Mountains, oceans, and even the air we breathe owe their existence to a restless interior. Without it, Earth would slowly smooth out. Mountains would erode into dust without new uplift to replace them. Volcanoes would crumble into extinct husks. The jagged, varied landscapes that make our world so rich would fade into flatness. It would take millions of years, but the trend would be clear. A world without a hot core would not be a dramatic, fiery apocalypse. It would be the opposite, It would be the slow suffocation of geology itself. The loss of geological activity would also silence Earth's creative force. New islands would no longer emerge in the oceans. Continents would never rearrange. The planet would stop inventing new shapes for itself. Compare this with the moon, which has been geologically dead for billions of years. Its surface is frozen in time, marked only by impacts from above, or compare with Mercury, its crust scarred by ancient wrinkles from when it cooled and shrank. These worlds are quiet, still, and barren. Earth, if its core cooled, would slowly join their company. Life would feel the consequences in ways both subtle and direct. Agriculture depends on fertile soils, which are enriched by volcanic ash and uplifted by tectonic activity. Without those processes, soils would degrade over time, losing nutrients faster than they are replaced. Ocean ecosystems, deprived of vents and mineral cycling, would decline. Even the climate system would shift toward extremes, no longer buffered by the steady renewal of gases from the interior. Humanity might survive for a while, building shelters, adapting with technology, but the living planet that sustained us, the partner in our survival, would no longer play its part. Psychologically, it would change how we think about Earth. We are used to fearing the violence of earthquakes, the unpredictability of eruptions, the destruction of tsunamis. But imagine generations growing up in a world where such events never happen. At first, it might feel safe, but then, slowly, the realization would spread. The reason for the silence is not protection, but loss. The planet is no longer alive. It is drifting towards stillness. And with stillness comes vulnerability. Because without geological renewal, without the dynamism of an inner fire, Earth becomes fragile. Its air can be stripped, its climates destabilized, its biosphere diminished. The silence is the beginning of the end, and yet we would not see it immediately. Geological death is slow. 100 lifetimes might pass before anyone truly noticed. That slowness is what makes it both deceptive and inevitable. The fire within Earth is not something we feel day to day, but it is what holds up the stage for all our history. The loss of that fire is not something that would come as a single event. It would creep into the background, gradually dimming the lights of a planet that once glowed with internal energy. So when we ask what if Earth's core cooled down, one answer is simple. The planet would grow quiet. Earthquakes would cease. Volcanoes would die. The crust would freeze into permanence. But hidden inside that quiet is a deeper truth. The planet that no longer moves is a planet that no longer breathes. The quiet is not peace. The quiet is an ending. Chapter 5. The End of Plate Tectonics. The surface of Earth looks steady, but in truth, it is floating, drifting, always in motion. Continents ride on massive slabs of crust, called tectonic plates, and those plates are pulled and pushed by the heat flowing from deep inside the planet. It is slow, only centimeters a year, but over millions of years it reshapes everything. Continents split apart and crash back together. Oceans open, then close. Mountains rise skyward, only to crumble again. That slow dance of plates is why Earth's surface has never stayed the same. It is also why life has endured, because the movement recycles materials and keeps the planet's systems balanced. But if the Earth's core cooled down, that movement would stop. And when plate tectonics stops, something far greater than geology ends. The planet itself begins to lose its rhythm. Plate tectonics is more than shifting land masses. It is the great circulatory system of the Earth. Hot material rises from the mantle, pushing plates apart at mid-ocean ridges. Old crust sinks back down into the mantle at subduction zones, carrying with it carbon, water, and minerals. This recycling regulates the atmosphere, the oceans, and even the chemistry of the surface. It is part of the reason Earth is habitable when other worlds are barren. Without plate tectonics, there is no renewal. There is only stagnation. Imagine what happens when the inner heat fades. The convection currents in the mantle weaken. The crust hardens, growing rigid. Subduction stalls. Mid-ocean ridges stop opening. The great conveyor belts of plate motion grind to a halt. For the first time in billions of years, continents freeze in place. Oceans keep their shape indefinitely. The map of Earth, once always shifting, becomes permanent. It may sound like stability, but in truth, it is decay. Mountains would erode without being rebuilt. The Rockies, the Alps, the Andes, all would be worn down by wind and rain until they were little more than rolling hills. Volcanoes would fall extinct, leaving behind silent craters and cold lava fields. Earthquakes would no longer rumble through fault lines, because the plates would no longer press or slip against one another. At first, this might seem like paradise, a quiet, unchanging world without natural disasters. But with that quiet comes a cost. The Earth would no longer breathe. One of the most important consequences of plate tectonics is the carbon cycle. When oceanic plates sink beneath continents, they carry carbon-rich sediments with them into the mantle. Some of that carbon is later released back into the atmosphere through volcanic eruptions. This cycle helps regulate global temperatures over millions of years. Without it, carbon would either build up uncontrollably or vanish from the atmosphere entirely. In the short term, it might mean less greenhouse gas, but in the long term, it would mean a world without balance, where the air can no longer sustain the rhythms of climate that life depends on. Water, too, is part of this cycle. Subduction carries water into the mantle, where it helps create magma and drives eruptions that return water to the surface. This circulation has kept oceans stable for billions of years. Without tectonics, the balance would break. Over immense timescales, oceans could shrink as water is lost to space or locked away in minerals with no return. A planet without plate tectonics is not just a planet without earthquakes. It is a planet where oceans themselves may vanish. To understand what such a world looks like, we can look at Venus. Venus is similar to Earth in size and composition, but its surface tells a different story. There are no plates. Instead, the crust is a stagnant lid. Heat builds beneath it until, occasionally, it bursts out in massive eruptions that resurface entire regions at once. The result is a planet that looks young, but it is geologically dead in the way Earth is alive. No slow recycling, no continents drifting, just bursts of catastrophe separated by long silence. If Earth's core cooled and tectonics stopped, our planet would slowly become more like Venus, or like Mars, which lost tectonics long ago. Life would feel this change in ways more profound than we might first think. Agriculture, for example, depends on fertile soil. Volcanic ash and uplift from mountain building replenish soils with nutrients. Without these processes, soils would slowly exhaust themselves. Food would become harder to grow. Ecosystems would weaken. Over time, Earth would lose much of its richness. Life might adapt, but the diversity we know today would fade. Humans, with our technology, might try to compensate. We might engineer ways to fertilize soil, capture carbon, or regulate climate artificially. But these would be patches, temporary solutions. The truth is that Earth's living systems are tied to its interior in ways we cannot fully replace. The end of plate tectonics would mean the end of Earth as a self-sustaining world. It would shift from being a planet that creates and renews to one that only consumes and erodes. There is another dimension to this thought. For billions of years, the surface of Earth has been a canvas for change. Mountains rise, continents move, oceans split, and life adapts to new environments. That constant change is what has driven evolution. When the plates stop, so does much of that environmental pressure. Evolution slows, diversity shrinks, life becomes more fragile. Without tectonics, Earth loses not only its geological creativity, but also its biological creativity. The planet becomes not just geologically dead, but biologically stagnant. And all of this would happen quietly. No single day would mark the end of tectonics. No warning sirens would sound. It would unfold over millions of years so slowly that no single generation would notice. Mountains would be slightly smaller, volcanoes a little less active, earthquakes less frequent. Then eventually, silence. Humanity might not even recognize the moment the plates froze, but the consequences would echo for as long as Earth remained. When we ask what if Earth's core cooled down, the answer is not only about a weakening magnetic shield or fading heat. It is about the loss of motion itself. The end of tectonics is the end of Earth's heartbeat as a planet. It is what separates a living world from a dead one. Mars is a graveyard of tectonic silence. Venus is a stagnant, suffocating oven. The moon is a frozen record of impacts. Earth is alive because its plates move, and they move because its core is hot. When that ends, Earth joins the still worlds, so the end of plate tectonics is not just geology. It is the slow unraveling of life's foundation. It is a world where mountains crumble without rebirth, where oceans stagnate, where the air loses its balance, where life itself weakens. A world without tectonics is a world without breath. And in imagining that, we see the true importance of the fire beneath our feet. It is not just heat. It is motion, renewal, and life itself. Chapter 6. Cooling atmosphere. When we talk about the Earth's atmosphere, we usually think of it as something separate from the ground beneath us. We imagine the air as a skyborne ocean, a blue dome held up by gravity, swirling with winds and clouds. But the truth is, the atmosphere is as much a product of the planet's interior as it is of its surface. To the gases we breathe, the balance of oxygen and carbon dioxide, the cycles of water and nitrogen, all of these have been shaped, replenished, and regulated by Earth's restless geology. The heat inside the planet is part of why the air above us is what it is. So if the Earth's core cooled down, the atmosphere itself would begin to change. Not immediately, not in a way we'd notice tomorrow or next year, but across the slow ticking of geological time. The atmosphere has always been tied to volcanic breath. When the Earth was young, its first thick atmosphere wasn't built by oceans or forests. It was exhaled by the ground. Volcanic eruptions poured out carbon dioxide, nitrogen, water vapor, and other gases. Over time, those gases collected, cooled, and settled into a sky. Later, life, tiny microbes, and eventually plants reshaped that sky, adding oxygen and pulling carbon back into stone. But the baseline supply, the constant refreshing of gases, came from below. Volcanoes acted like lungs, slowly keeping the balance. If Earth's core cooled and volcanoes fell silent, those lungs would stop breathing. At first, this would mean less carbon dioxide entering the atmosphere. To some people, that might sound like a blessing. After all, carbon dioxide traps heat and contributes to global warming. But in the long view of planetary health, carbon dioxide is not a villain. It is a regulator. Too much, and the planet overheats. Too little, and the planet freezes. Volcanic release keeps that balance in motion. Without it, the level of greenhouse gases would slowly decline. Plants would struggle because they depend on carbon dioxide to photosynthesize. Forests would weaken, crops would yield less, and ecosystems built on plant life would falter. A decline in carbon dioxide could also trigger global cooling, pushing Earth into deeper ice ages from which it might never emerge. Oxygen, too, would eventually decline. Life creates oxygen through photosynthesis, but oxygen doesn't stay in the air forever. It reacts with rocks, with organic matter, with the chemistry of the planet. Normally, tectonics and volcanism recycle buried carbon and nutrients back into circulation, indirectly supporting oxygen production. Without that recycling, oxygen levels would become harder to maintain. Generations might pass before the change was obvious, but eventually the air would thin of oxygen, not in pressure, but in proportion. Breathing would become more difficult, first at high altitudes and later everywhere. Life would adapt where it could, but diversity would shrink. The atmosphere's temperature regulation would also falter. Right now, volcanic eruptions periodically inject aerosols into the stratosphere, tiny particles that reflect sunlight and temporarily cool the climate. It is one of nature's ways of balancing extremes. Without eruptions, those natural safety valves disappear. The climate would swing more widely, less buffered by the planet's interior. Storms, droughts, and long-term shifts could become more unpredictable. The atmosphere would still move, but its dance would be unsteady, more vulnerable to external nudges from the sun or from cosmic events. Another factor is the loss of the magnetic field, which we imagined in the earlier chapter. Without a strong magnetosphere, the solar wind would strip the upper atmosphere away. Molecules of hydrogen and oxygen would be lost to space, little by little, thinning the protective layers. The ozone shield, which blocks harmful ultraviolet radiation, would weaken as well, bombarded by unfiltered solar particles. The sky above us would still look blue, but it would no longer be the secure blanket it once was. Radiation would pour through more easily, making the surface a harsher place to live. The oceans, inseparably linked with the atmosphere, would feel this cooling too. Water vapor cycles depend on volcanic release and tectonic circulation. Without the core's heat, there would be less evaporation driven by geothermal activity, fewer geysers and hot springs feeding the air with moisture. Over immense spans of time, the hydrological cycle would weaken, clouds would thin, rainfall would shift. Regions that once depended on steady rainfall could dry out, while others might freeze under lingering cold. The atmosphere would still circulate, driven by sunlight and rotation, but it would lose the deep hidden energy from below that has always steadied it. This slow suffocation of the atmosphere would not arrive in a single moment of crisis. It would creep in quietly. Crops would become less reliable. Forests would decline. Certain animals would vanish as their oxygen needs could no longer be met. Humans might build domes or engineer enclosed systems, creating artificial atmospheres to survive. But outside those bubbles, the world would grow thinner, drier, colder, and harsher. The sky would no longer be a shared, life-giving ocean. It would be a fragile, dwindling resource. And yet, for millions of years, life might still cling on. Microbes would adapt. Some plants would survive in niches. Humanity might stretch technology to compensate. The atmosphere would not vanish overnight, but its slow unraveling would remind us of how deeply tied the sky is to the fire beneath our feet. We think of air as coming from the heavens, but in truth, it is born of rock, water, and heat. Without the furnace of the core, the lungs of the earth begin to fail. So what if Earth's core cooled down and the atmosphere followed? It would mean more than a loss of warmth. It would mean the gradual thinning of the very breath of the planet. A sky that was once balanced would turn unstable. A climate once buffered would swing wildly. Oxygen and carbon dioxide, once maintained by hidden cycles, would drift out of sync. And life, dependent on the chemistry of air, would be forced to retreat. The silence of volcanoes would echo upward into the air itself. The stillness of tectonics would spread into the climate. The cooling of the core would ripple outward until even the atmosphere was not what it once was. The end of the Earth's heat would not only freeze the crust, it would slowly suffocate the sky. Chapter 7. Oceans without heat. The oceans have always been mirrors of the Earth's interior, though we rarely think of them that way. We picture the sea as a realm ruled by the sun and the moon, by surface winds, tides, and storms. But hidden beneath the waves is another kind of power, one that comes not from above, but from below. The deep ocean is stirred and energized by the heat that seeps up from Earth's core. It is a quiet contribution, often invisible to us on land, but it is vital. Without it, the oceans would be colder, emptier, less alive. And if Earth's core cooled down, the oceans would lose this hidden fire. They would become still. At the bottom of the sea, along cracks in the crust, there are hydrothermal vents, fissures where seawater seeps down, is heated by magma, and bursts back upward in plumes of scalding water. These vents gush minerals, metals, and chemical energy into the deep sea. Around them, ecosystems thrive in complete darkness. Strange organisms cluster near the vents. Giant tube worms with blood-red plumes, clams the size of dinner plates, blind shrimp glowing faintly in the dark. They do not rely on sunlight. Instead, they rely on chemosynthesis, a process in which bacteria use the vents' chemicals as fuel. These bacteria form the foundation of entire food webs, feeding creatures that no human had even imagined before their discovery in the late 20th century. Some scientists believe life itself may have begun in places like this. Billions of years ago, when the Earth was still young, hydrothermal vents may have been the perfect cradle. Warmth, water, minerals, and chemical gradients provided the ingredients for the first self-replicating molecules. If that is true, then every living thing today carries a legacy of the Earth's hidden heat. Life is not only tied to the sun, but also to the fire inside the planet. Now imagine the core cooling down. The magma chambers beneath the ocean floor would die away. The plumes would weaken, then cease. Hydrothermal vents would go dark. The ecosystems built on them would vanish, entire communities collapsing into silence. It would not be a dramatic extinction in the way an asteroid strike wipes out species. It would be a slow fading, as one by one, the organisms that depended on those vents found nothing left to sustain them. The deep ocean, already mysterious and vast, would become emptier still. But vents are not the only way the core feeds the ocean. Heat from the Earth's interior helps drive circulation. At mid-ocean ridges, where tectonic plates pull apart, magma rises to form new crust. This constant renewal shapes the ocean basins and influences currents. Without the churning of the mantle, ridges would fall dormant. The renewal would stop. The seafloor would age without replacement, growing cold and heavy. Ocean circulation patterns, already delicate, would begin to shift. Consider the great conveyor belt of the sea, the thermohaline circulation. This system moves water around the globe, carrying warm water from the tropics toward the poles and bringing cold, nutrient-rich water back up from the depths. It is essential for regulating climate and feeding marine life. While it is mainly driven by differences in temperature and salinity, geothermal heat plays a role in keeping the deep waters moving. Without it, the deep layers of the ocean would grow more stagnant. Nutrients that normally rise from the bottom would stay trapped. Fisheries would collapse. Coral reefs and coastal ecosystems would suffer. Life in the oceans, already stressed by surface changes, would wither from below as well. The cooling of the core would also change the chemistry of the oceans. Hydrothermal vents not only provide heat, but also inject elements like iron, manganese, and sulfur into the sea. These trace minerals feed plankton blooms and shape the cycles of the ocean's chemistry. Without them, the balance of nutrients would tilt. The great cycles of nitrogen, phosphorus, and carbon would falter. Oceans might become less capable of absorbing carbon dioxide from the atmosphere, accelerating climate shifts. The partnership between sea and sky would weaken, leaving both less stable. We often think of the ocean as eternal, as if the waves and tides will always move the same way. But the truth is, the ocean is alive because the earth beneath it is alive. Remove the fire from within, and the ocean becomes just water, a vast, still reservoir without its hidden engine. Its depths would grow colder, its circulation weaker, its ecosystems poorer. It would remain an ocean, but it would no longer be the dynamic, life-sustaining ocean we know today. For humanity, this would bring challenges we can barely imagine. Fisheries would collapse without nutrient cycles. Weather patterns, tied to ocean circulation, would grow more erratic. Coastal communities would face unpredictable storms, not because of more energy in the system, but because the system itself had lost its steady rhythm. The oceans would no longer buffer climate in the same way, making the atmosphere harsher. And perhaps the greatest loss would be philosophical. For as long as humans have looked at the sea, we have seen it as endless, mysterious, full of secrets. But its greatest secret has always been that it is connected to the fire beneath our feet. The ocean is not separate from the core. It is an extension of it, a surface expression of the planet's inner fire. Without that connection, the sea becomes less of a mystery and more of a mirror, cold, still, reflecting the death of the planet's interior. In the far future, if Earth's core truly cooled, our descendants might look at the oceans and see only water, still and lifeless, compared to what it once was. They might dig into the crust and find fossilized vent systems, the skeletons of tube worms preserved in mineral chimneys, remnants of a time when the deep sea burned with hidden fire. They would know then that the oceans they inherited were shadows of what once had been. So what if Earth's core cooled down and the oceans lost their heat? It would mean more than silence at the seafloor. It would mean the end of one of the most important engines of life on Earth. It would mean the slow fading of the cycles that connect water, air, and rock. It would mean an ocean that still moves with tides and winds, but no longer with the pulse of the planet itself. The sea, like the sky, would become a record of loss. A reminder that the fire inside the earth does not only shape the land beneath our feet, it reaches into the deepest trenches, the darkest waters, and the most fragile webs of life. Without that fire, the oceans would not disappear, but they would no longer be alive. Chapter 8. The Sky Burns. When we stand outside on a sunny day, we rarely think about the sky as dangerous. The warmth on our skin, the glow of light, the breeze moving the clouds. It feels gentle, protective, but that gentleness hides a truth. The sky is only safe because something invisible shields it, Earth's magnetic field. Without that shield, the sky becomes a place of fire. If the Earth's core cooled down and the magnetic field died with it, the sky would not simply grow thinner, it would begin to burn. The sun is not a calm star. It is a raging sphere of plasma, constantly sending out streams of charged particles called the solar wind. These particles race through space at hundreds of kilometers per second, colliding with anything in their path. Right now, Earth's magnetic field deflects most of them, bending them around the planet in arcs that form the magnetosphere. But if the dynamo in the core faded, the magnetosphere would collapse. The solar wind would strike the atmosphere directly. At first, we would notice it as light. The auroras, those shimmering curtains usually confined to polar skies, would become global. Everywhere on Earth, people would see the skies glow green, purple, and red as solar particles slammed into the atmosphere. It would look beautiful, but the beauty would carry danger. The lights would be warnings, signs that radiation was breaching the sky. The atmosphere would begin to erode, stripped atom by atom into space. Hydrogen, oxygen, and nitrogen molecules would be peeled away by the relentless wind, the same way paint is worn off by sandblasting. Over thousands of years, this stripping would thin the atmosphere. The higher layers would vanish first, the exosphere and thermosphere, leaving the planet more vulnerable to ultraviolet light. The ozone layer, already fragile, would weaken further under constant bombardment. On the ground, radiation would increase. Sunlight would not feel safe anymore. The sky would carry with it an invisible hazard, one that could sicken or kill slowly, leaving marks in DNA and accelerating cancers. The technological world we depend on would also feel the burn. Satellites, no longer shielded, would face constant damage from charged particles. Solar storms, which today can cause temporary blackouts or disruptions, would become catastrophic. Entire networks could collapse. GPS would falter, communications could vanish, and international infrastructure would be at constant risk. Air travel, especially near the poles, would become dangerous, exposing passengers to radiation levels once reserved for astronauts. But beyond technology, it would be life itself that suffered. Cosmic rays, normally deflected by the magnetosphere, would now reach the surface more freely. These high-energy particles penetrate deeply, mutating DNA. Some species might adapt. Mutations are, after all, part of evolution, but the rate of harmful changes would far outpace beneficial ones. Many organisms, especially those near the surface or in open skies, would face collapse. Plankton, the foundation of marine food webs, would decline, sending ripples up through the chain of life. Crops would yield less as radiation damaged their cells. Animals and humans would struggle with higher rates of disease. Over time, the erosion of the atmosphere would reshape the climate. With less air to trap heat, nights would grow colder, days hotter, weather less stable. The greenhouse effect, weakened by the loss of gases, could plunge Earth into a colder world, even as radiation from the sun scorched the surface. It would be a paradoxical planet, a place where the sky burned but the ground froze. Mars is our closest reminder of what this looks like. Billions of years ago, Mars likely had rivers and lakes, but its smaller size meant its core cooled quickly. Without a dynamo, its magnetic field vanished. The solar wind stripped away much of its atmosphere, leaving behind only a thin shell. Today, the Martian sky does not protect. It exposes. Radiation from space bombards the surface constantly, one of the greatest challenges to future colonization. If Earth's core cooled, our planet would begin the same slow march toward a Martian fate. Yet it would not happen overnight. Generations would pass before the atmosphere thinned significantly. For a long time, humanity might adapt. We might build radiation shelters, live underground or in domed cities, develop artificial shields using magnetic fields or plasma screens. Technology could delay the consequences, even soften them, but the long-term truth would be inescapable. The sky above us, once protective, would become hostile. To step outside unprotected would be to risk constant exposure to invisible fire. The psychological impact would be immense. For all of human history, the sky has been our canvas of wonder. We have looked up and seen safety, beauty, hope. But in a world without a magnetic shield, the sky would be a reminder of danger. The glowing auroras would no longer inspire myths of gods and spirits. They would be signs of decay, markers of a world slowly unraveling. The sun, once our source of life, would feel more like an enemy, sending storms and flares we could no longer block. And yet, within that danger is a lesson. We often think of the atmosphere as belonging to the air itself, but the truth is, the atmosphere exists in its current form only because of the fire inside the Earth. The connection between the core and the sky is invisible but profound. Without the inner heat, the shield fails. Without the shield, the sky burns. And when the sky burns, the ground itself becomes unlivable. So what if Earth's core cooled down? The answer is not only in the silence of volcanoes or the stillness of continents. It is in the fire that would move to the sky. The invisible protection we rely on would vanish. The sun's wind would strip away our air. Its radiation would scar our DNA, and the very sky that comforts us now would turn against us. The Earth would not be destroyed in a single blow, but day by day, year by year, the burn of the solar wind would write a new story across the heavens. A story of loss, of vulnerability, and of a world that once glowed blue beneath a living shield, but now glows red and green with auroras that are not gifts, but warnings. Chapter 9. Life on the Surface. For billions of years, the Earth has been more than just a planet. It has been a sanctuary. Life has thrived here, not because existence is easy, but because the planet provides balance. The core burns, the mantle moves, the magnetic shield deflects, and together they create a stage on which life can flourish. But if the Earth's core cooled down, that balance would begin to fracture. The shield would fade, the air would thin, the oceans would weaken, and on the surface where we live, farm and build, the consequences would be felt most directly. At first, the changes might be subtle. The soil would still feel fertile, the rain would still fall, and the seasons would still turn. Generations might pass before the first real signs appeared, but slowly, the damage would spread outward. Radiation from space would become a daily presence. The weakened atmosphere would no longer block as much ultraviolet light or cosmic rays. To us, that would mean more than just harsher sunburns. It would mean genetic damage accumulating in plants, animals, and humans. For agriculture, this would be devastating. Crops already struggle under today's challenges: droughts, heat waves, shifting climates. Add unfiltered radiation, and yields would plummet. DNA damage would stunt growth, reduce fertility, and increase crop failure. Farmers would find themselves battling forces invisible to the naked eye. The global food supply, so delicately balanced, would falter. Regions that once produced abundance would face scarcity. Hunger, already a challenge in parts of the world, would spread even in places that had once been stable for ecosystems. The effects would ripple through the food chain. At the base of many ecosystems are the smallest organisms: plankton in the oceans, grasses on land, insects in forests. These creatures are sensitive to radiation and climate changes. As they decline, larger species lose their foundation. Fish stocks would collapse as plankton dwindled. Grazing animals would starve as grasses weakened. Predators, including humans, would find their food chains unraveling. The surface of Earth, once rich with life, would become patchier, with pockets of survival in places that offered natural shelter from radiation. Human health, too, would shift in ways we cannot ignore. Today we worry about the risks of radiation in medicine, in power plants, in space travel. But those risks are limited by shields and protections. In a world without a magnetic field, those risks would be everywhere. Skin cancers would rise dramatically. Genetic disorders would become more common as mutations accumulated. Pregnancies would be harder to carry safely. Lifespans could shorten, and populations might dwindle, not because of a single catastrophe, but because of a slow erosion of health over centuries. Some societies might adapt. Underground cities could shelter people from radiation, their ceilings lined with rock to block cosmic rays. Artificial atmospheres could be built in domes, controlled and filtered to mimic the protective sky Earth once had. Crops might be grown in sealed greenhouses under artificial lights, shielded from harmful rays. Technology could delay the worst consequences, allowing human civilizations to continue in controlled environments. But this would not be the same as living freely on a generous planet. It would be survival in bubbles, a retreat from a surface that had once been home. The psychological toll would be immense. For all of human history, we have lived under an open sky. We have looked upward for inspiration, for meaning, for reassurance that the world is wide and welcoming. To lose that, to live knowing that stepping outside exposes you to invisible radiation, would change our relationship with the planet itself. Children might grow up never playing under the open sun. Farmers might tend their crops only in sealed chambers. The idea of wilderness, of nature, untamed and free, would fade into memory. Animals lacking technology would fare worse. Some species might adapt through rapid mutation. Insects with short life cycles might evolve resistance more quickly. But large mammals, birds, reptiles, they would struggle. Extinctions would accelerate. Forests would thin. Grasslands would empty. The great diversity of Earth, once a signature of its vitality, would shrink. Over time, the planet would resemble the barren deserts of Mars or the stagnant plains of Venus, not in appearance, but in the silence of lost life. And yet, even in this grim vision, there would be resilience. Life on Earth is astonishingly persistent. Extremophiles, bacteria that thrive in radiation, heat, or ice, would likely continue. Underground fungi, deep-sea microbes, shielded cave ecosystems, they might endure even as the surface grows hostile. Evolution would not stop. It would simply move in directions unfamiliar to us. The surface might empty, but in hidden places, new forms of life would slowly emerge, shaped by the new environment. The cooling of the core would not only threaten life physically, it would also strip away the invisible rhythms that have sustained it. Plate tectonics recycles nutrients. Volcanoes replenish the atmosphere. Ocean circulation distributes heat. Without these processes, ecosystems would not just be damaged by radiation, they would starve. Fertile soil would lose nutrients without volcanic ash to renew it. Oceans would stagnate without hydrothermal vent minerals. Even the simplest organisms would struggle without the quiet gifts once given by a living Earth. For humanity, survival might depend on leaving the surface altogether. Colonies could be built underground, beneath mountains, or inside sealed arcologies. Perhaps entire populations would retreat into artificial habitats orbiting the Earth. Looking down at a planet that once gave freely but no longer could, the Earth would remain a planet of memory, a place that still turned in space but no longer sustained its own children. So what if Earth's core cooled down and life on the surface was left unprotected? It would mean a slow collapse of abundance. Fields would fail, forests would thin, oceans would grow barren. The air would still be there, but poisoned by radiation and stripped of its balance. Humans might survive through ingenuity, but survival would replace flourishing. The surface, once the stage of history, would become a danger zone, visited rarely, lived on reluctantly, remembered fondly, but feared in reality. It is haunting to imagine, because the Earth we know today is generous beyond measure. It grows food, it filters air, it shields us without asking anything in return. We walk on the surface as though it will always be safe, but its safety depends on a fire far below us. And if that fire ever faded, life on the surface would not end in an explosion or a sudden catastrophe. It would end slowly, in silence, as radiation crept in, soils depleted, and ecosystems unraveled. In that silence, the true cost would not just be measured in lives lost or habitats destroyed. It would be measured in the loss of freedom, the freedom to live under an open sky, to walk the earth without fear, to see the world as a home rather than a hazard. Without the core's heat, the surface itself would no longer belong to us. Chapter 10: Technology at Risk. When we think about Earth's core, we imagine geology, volcanoes, mountains, earthquakes, things of rock and stone. Rarely do we think about satellites, internet cables, or power grids, and yet our entire technological world is tied, invisibly, to the fire beneath our feet. The molten core drives the magnetic field, and that field shields our machines as much as it shields our bodies. If the Earth's core cooled down, it would not just be life on the surface that suffered. It would be our technology, the fragile web we have woven around the planet to hold our civilization together. Start with the satellites. Right now, thousands of them orbit above us, circling the Earth in paths that keep them safe inside the magnetosphere. They provide GPS, weather forecasts, communications, banking, television, everything that stitches our modern world into a functioning system. Without the magnetic shield, every one of those satellites would be exposed to the raw force of the solar wind. High-energy particles would slam into their circuits, corrupting data, frying boards, and degrading solar panels. Satellites would age not in decades, but in years or even months. Maintaining global networks would become an endless struggle, like trying to build sandcastles in the tide. Down on Earth, the same storms that destroyed satellites would also strike our power grids. We have seen glimpses of this already. In 1989, a solar storm caused a blackout in Quebec, leaving millions without power for 9 hours. That happened with the magnetosphere still in place. Without it, such events would be magnified. Solar flares would induce powerful electric currents in transmission lines, overloading transformers and tripping breakers across entire regions. Blackouts could last not hours but weeks. In some cases, damaged infrastructure might take months to replace. Modern cities, dependent on electricity for everything from water pumps to hospitals, would be paralyzed. Communication systems would falter too. Radio waves bounce off the ionosphere, a layer of charged particles held in place by the magnetic field. If the shield collapsed, the ionosphere would be unstable, constantly shifting as the solar wind stripped it away. Radio signals would scatter or vanish unpredictably. Air traffic control, long-range communication, even basic broadcasts would be unreliable. The global internet, routed through satellites and undersea cables, would be vulnerable at every step. Society, as interconnected as it is, would find itself thrown back into fragmentation. Air travel would face unique risks. Today, planes flying near the poles sometimes reroute during strong solar storms because of radiation levels. Without the magnetosphere, that danger would be constant. Passengers and crew would be exposed to doses of radiation once limited to astronauts. Airlines would need to reroute permanently or build shielding into planes, raising costs and reducing safety. Air travel, once routine, could become a privilege too dangerous to maintain at its current scale. Space exploration would be changed even more. Astronauts rely on Earth's shield as much as anyone on the surface. The International Space Station sits within the magnetosphere, giving its crew protection. Without it, astronauts would be bombarded with cosmic rays at levels that would make long stays impossible. Missions to the Moon or Mars, already perilous, would become nearly suicidal without heavy shielding. Human dreams of exploring space would shrink back, not expand. We would retreat, bound not just by technology but by the loss of a planetary gift we once took for granted. Even underground technologies would be at risk. The solar storms that fry satellites also penetrate power systems, pipelines, and data cables. They induce currents that corrode metals, degrade insulation, and overload systems. Our deepest technological veins, undersea cables stretching across continents, would fail more often, forcing expensive and constant repairs. The global economy, dependent on fast connections, would shudder. We sometimes think of technology as standing apart from nature. We build machines to escape it, to control it, to live above its rules. But the truth is, our machines are even more vulnerable than we are. A human can hide in a cave to avoid radiation. A plant can adapt over generations, but a satellite cannot. A transformer cannot. Our machines do not evolve, they break, and without the shield of Earth's magnetic field, they would break often. This fragility would change society in profound ways. Imagine cities where power flickers on and off, unpredictably, where flights are delayed not by weather, but by radiation storms, where GPS is unreliable, where banking systems crash under solar interference. Imagine a world where every major solar flare is a global crisis, shutting down grids, collapsing communications, forcing governments and companies into constant repair. That world would not look like the smooth, connected civilization we know. It would be jagged, unstable, uncertain. Of course, humanity would try to adapt. Scientists might attempt to build artificial shields, giant magnetic fields powered by enormous energy supplies, perhaps stationed in orbit as protective barriers. Engineers might design hardened satellites, circuits resistant to cosmic rays, planes with radiation-proof hulls. But these solutions would be costly, imperfect, and limited. The scale of the problem is planetary, and the solutions would never match the effortless shield the Earth once gave us for free. The irony is striking. We think of technology as our great strength, our advantage over nature. But in this scenario, it is also our great weakness. Life on Earth, in its rawest forms, could continue without satellites, without GPS, without grids. But we could not. Civilization as it is built today depends on a steady flow of information and power. Remove that, and the most advanced age in human history might find itself brought to its knees by storms from the sun. So what if Earth's core cooled down and technology faced the full force of the sky? It would mean a world where every machine was vulnerable, where progress was slowed not by lack of knowledge, but by lack of protection. It would mean a step backward, not in imagination, but in capability. It would mean a civilization forced to accept fragility, building shelters not only for bodies, but for wires and circuits, struggling to preserve networks in a universe that no longer shields them. And in that struggle, we would learn a humbling truth, that all along, our greatest technology was not one we built, but one we inherited. The molten iron spinning in the dark beneath our feet, the invisible field stretching into space. That was our first shield, our first gift, our first infrastructure. And when it fades, no satellite, no machine, no grid will replace it perfectly. The Earth's core is not just geology. It is the foundation of everything we have built on its surface, from forests to fiber optics. Without it, our machines, like us, will be left exposed. Chapter 11. Searching for shelter. If Earth's core cooled down and the shield above us faded, survival on the surface would no longer be easy. Radiation would slip through the weakened sky, food chains would fray, technology would fail more often, and life would feel less secure. Humanity, so used to relying on Earth's natural protection, would be forced to confront a stark question. Where do we go when our planet can no longer shelter us? The answer, most likely, is inward. We would have to search for shelter beneath the very crust that once depended on the fire inside. Underground living has always been a part of human history. Ancient people sought caves for safety from storms, predators, and enemies. Even today, some communities build underground homes to escape extreme heat or cold, but in a world without the core's shield, caves would no longer be optional. They would be essential. Rock is one of the best protectors against radiation. A few meters of stone can block what the sky no longer can. If the surface grew too harsh, humanity would retreat downward, building cities beneath mountains, burrowing into old mines, carving out vast caverns lit with artificial suns. These underground cities would look nothing like the sprawling metropolises of today. Instead of skylines and towers, they would be networks of tunnels and chambers, carefully ventilated and engineered. Farms would be hydroponic, grown under LED lights, powered by whatever energy systems still worked. Rivers might be tapped to run underground turbines. Air would be filtered, oxygen enriched, carbon dioxide scrubbed away. It would be a controlled environment, more like a spacecraft than a natural home. On the surface, the Earth would still turn, but life would be hidden below, cautious and shielded. Of course, not all life could follow us underground. Forests, oceans, and open grasslands cannot retreat. They would continue to suffer as radiation intensified and nutrients dwindled. The surface would grow emptier. What remained above would be the toughest survivors, radiation-hardened microbes, perhaps insects or mutated plants, able to cope with harsher conditions. Humanity, with its technology, would survive, but we would live separated from the natural world that once defined us. The songs of birds, the sight of open skies, the feel of sunlight on skin. These would become rare luxuries, experienced only through controlled exposure or in memories passed down. Shelter would not only mean physical protection, it would also mean psychological adaptation. Imagine children raised entirely underground, who never see the stars with their own eyes. For them, the sky might become legend, something spoken of but not experienced. The concept of day and night would be replaced by artificial cycles of light and dark. Our connection to the natural rhythms of Earth would fray. Humanity would continue, but our culture, our sense of belonging to the planet, would change forever. Some might attempt to build domed cities on the surface instead of burrowing below it. Transparent shields, perhaps layered with radiation-blocking materials, could allow people to live under the sun while still protected. These domes would be marvels of engineering, self-contained ecosystems, sealed from the dangers outside. Within them, grass could grow, children could play, and communities could look upward without fear. But such structures would require immense resources to maintain, and they would always be vulnerable to damage. A crack, a failure in shielding, a powerful storm could endanger everyone inside. Others might turn to the seas for shelter. Beneath the water, radiation is absorbed and scattered, making the deep ocean a safer place than the surface. Entire civilizations might move to undersea habitats, living in pressurized domes or floating cities tethered to the seabed. These aquatic shelters could host farms, fisheries, and research stations, all while using the ocean itself as a natural shield. But again, the cost would be high, and the challenge is immense. Humans are not naturally creatures of the deep, and making the ocean a permanent home would mean pushing our technology further than ever before. The search for shelter would also extend beyond Earth. With the surface compromised, the drive to colonize space would grow stronger. Mars, despite its own lack of magnetic shield, might be made livable with underground bases and artificial domes. The Moon could host colonies carved into lava tubes. Even orbiting stations far larger than anything we have today might serve as sanctuaries for parts of humanity. Ironically, the very condition that made Earth harsh, loss of its natural shield, would push us to live in ways more like the worlds we once thought inhospitable. But shelter, no matter how advanced, would never be a true substitute for what we lost. Living underground, in domes or under the sea, would keep us alive, but it would sever us from the open landscapes that shaped our evolution. We are creatures who grew under sunlight, in forests, across plains, and along coasts. The sky has always been part of our psychology, our art, our sense of wonder. To hide from it would change us at a fundamental level. Survival would continue, but the experience of being human would be different. And yet, even in this grim scenario, there would be resilience. Humans have always adapted, from the ice ages to the deserts, from mountaintops to islands. We have found ways to endure. The loss of Earth's core heat would be a challenge greater than any we have known, but not insurmountable. Underground cities could thrive. Domed habitats could flourish. New cultures, new ways of life would emerge. Our descendants would grow up in these shelters not as exiles, but as citizens of a new kind of Earth. They would see themselves not as people hiding from the world, but as people who built a new one inside it. Still, the thought lingers. If Earth's core cooled and we were forced into shelter, it would mark the end of a chapter in planetary history. For billions of years, the surface of Earth has been home to life, open and free. To lose that would be to lose part of what makes our planet unique. Shelter would keep us alive, but it would also remind us of what we no longer have: a world where the Earth itself protected us, where the sky was safe, and where survival did not mean retreat. So what if Earth's core cooled down and humanity searched for shelter? It would mean burrowing into stone, building domes against radiation, retreating into the sea, and reaching for the stars. It would mean survival, but not freedom. It would mean endurance, but not the same connection to the open world. Shelter would be our salvation, but also our reminder. A reminder that Earth's greatest gift was not only its surface, oceans, or forests. It was the fire within, a shield we never built, but always needed. Chapter 12. Lessons from Other Worlds. When we imagine the Earth's core cooling, we don't need to rely only on speculation. The solar system offers us examples, neighbors that have already walked that path. Mars and the Moon, Mercury, and even distant icy bodies all tell us stories of what happens when a planet or a moon loses its inner fire. By studying them, we see glimpses of Earth's possible future, and the lessons are sobering. Mars is the clearest mirror. Billions of years ago, Mars may have looked far more like Earth. Geological evidence shows valleys carved by rivers, ancient lakebeds, and perhaps even oceans. Its atmosphere was thicker, its climate warmer, its surface wetter. For a time it might have been habitable, even welcoming. But Mars was smaller than Earth, and that difference sealed its fate. A smaller planet loses heat faster. Its molten core cooled more quickly, and as it cooled, its dynamo sputtered out. Without the dynamo, there was no magnetic shield. Without the shield, the solar winds stripped the atmosphere away. Over millions of years, Mars transformed from a living, dynamic planet into a cold desert. Today its surface is barren, its air thin, its rivers frozen into memory. When we look at Mars, we see what Earth could become if its core cooled, a planet stripped of its shield, its air, and much of its life. The Moon tells a different story. Our nearest neighbor once had volcanic activity. Ancient lava plains, called Maria, still darken its face. These vast fields are frozen evidence of a time when molten rock welled up and flooded craters. But that time is long past. The Moon's small size meant its core cooled quickly, ending tectonics, eruptions, and geological renewal. The surface we see through telescopes is a fossil, unchanged for billions of years, except by impacts from space. Without an atmosphere or magnetic field, the Moon is exposed directly to radiation, its soil laced with particles from the solar wind. If Earth's core cooled completely, our planet could eventually resemble the Moon, not in appearance, because Earth has oceans and air, but in stillness. The surface would become a frozen record of past activity, a place without renewal, where change comes only from erosion and bombardment. Mercury offers yet another lesson. Despite being the closest planet to the Sun, Mercury has almost no atmosphere to shield it. It is scarred with cliffs and ridges called lobate scarps, formed when the planet shrank as its core cooled and contracted. Imagine a whole world wrinkling as it lost its inner heat. Earth, if its core cooled enough, might not shrink in the same way because of its larger mass. But the principle is clear. Cooling changes the very shape of a planet. It alters not only its surface, but its structure. Even icy moons like Europa or Enceladus hint at the importance of heat within. These distant worlds, orbiting Jupiter and Saturn, are far from the Sun and should be frozen solid. Yet beneath their icy crusts, oceans of liquid water remain, warmed by tidal heating, the constant flexing caused by gravitational pull. Where there is heat, there is motion, and where there is motion, there may be life. Scientists speculate that hydrothermal vents on Europa's ocean floor could resemble those on Earth, fueled by hidden warmth. The lesson is clear. Heat is the difference between static worlds and dynamic ones, between barren ice and the possibility of life. These examples remind us that Earth's situation is not unique. Heat is fleeting, even in planets. Given enough time, every world cools, every dynamo dies, every shield collapses. Earth is fortunate because it is large enough to retain heat for billions of years, and radioactive decay inside the mantle continues to fuel its engine. But one day, even that will not be enough. The comparison with Mars is especially haunting because it is so familiar. Mars is not alien in the way gas giants or distant moons are. It is rocky, with mountains, valleys, deserts, and polar caps. It had rivers and lakes, climates and seasons. When its core cooled, it lost not only its shield, but its potential to remain alive. Looking at Mars is like looking at Earth's ghost, a preview of what happens when the inner fire fades. The thought that Earth might one day follow makes our own shield feel less permanent, less guaranteed. These lessons teach us humility. We often think of Earth as uniquely stable, uniquely safe, but its safety is conditional. It is tied to factors we cannot control: its size, its heat, its composition. If any of those had been different, Earth might have ended up like Mars, Venus, or the Moon. Our habitable sky is not a permanent gift. It is a stage in a long story, a temporary balance that allows life to flourish. They also teach us resilience. Even as planets cooled and shields collapsed, remnants of dynamism linger. Mars still has frozen water beneath its surface. The Moon, though geologically quiet, still records impacts that tell us about the solar system. Europa and Enceladus, with their subsurface oceans, remind us that heat does not only come from cores, but from motion and gravity. Life clings to warmth wherever it finds it, even in the darkest, most unlikely places. If Earth's core cooled and its shield failed, life here would not vanish immediately. It would retreat, adapt, survive in niches. Humans might build shelters underground, domes on the surface, or colonies elsewhere. Microbes would persist, fungi would endure, and evolution would continue. The lesson from other worlds is not only about loss, it is about persistence. Worlds can grow quiet, but life often finds ways to whisper on. So what if Earth's core cooled down, and we look to other planets for guidance? Mars would warn us of atmospheric loss. The Moon would show us geological stillness. Mercury would reveal structural change. Europa and Enceladus would remind us that heat, no matter its source, is the spark of possibility. Together, they tell a single story. Without inner fire, a world becomes fragile. With it, a world can thrive. When we look up at the night sky, we see these worlds as distant points of light, but in truth, they are mirrors. They show us what we are, what we were, and what we may become. They teach us that Earth's core is not just a feature of our planet. It is our shield, our motion, our balance, our chance at life. And like all things in the universe, it is temporary. The lesson is not to despair, but to appreciate, to recognize that the fire inside Earth is a gift, one that other worlds have already lost. With Chapter 13, the slow geological death. If Earth's core cooled down, the end would not come with fire or explosions. It would come with silence. Planets do not die the way stars do, with sudden bursts of brilliance. They fade instead, their energy slipping away bit by bit until motion ceases. For Earth, that fading would be the slow geological death of a world, a death measured not in days or centuries, but in millions of years. We sometimes think of geology as background scenery, as if mountains, oceans, and continents are static backdrops for the human story. But geology is alive. The continents drift, volcanoes erupt, earthquakes ripple. These are the signs of a living interior. Beneath our feet, convection currents move through the mantle like slow tides. The heat escapes upward, carrying energy that reshapes the surface again and again. But when the core cools, those tides weaken, the energy dwindles. And one by one, the signs of geological life disappear. The first loss would be volcanism. Without a hot interior, magma would no longer rise through cracks in the crust. The great arcs of volcanoes, the Andes, the Cascades, the Pacific Ring of Fire would grow quiet. Lava would freeze deep below the surface, never reaching daylight. The dramatic plumes of ash, the fiery rivers of molten rock would vanish. At first, this might seem like relief. No more eruptions to bury cities or blacken skies. But it would also mean no more renewal. Volcanic ash, rich in minerals, fertilizes soils. Eruptions recycle carbon dioxide into the atmosphere, balancing greenhouse gases. The silence of volcanoes would mean impoverished soils, stalled carbon cycles, and a world losing its self-regulation. Then earthquakes would fade. Without mantle convection, tectonic plates would grind to a halt. Subduction would cease. Mid-ocean ridges would stop spreading. The restless puzzle of the crust would lock into its final arrangement. Fault lines would go quiet. Cities that once feared tremors would no longer shake. Again, it might sound like safety, but in truth, it would be stagnation. The Earth's crust would no longer be renewed. Old seafloor would remain unconsumed by the mantle. Continents would erode without being rebuilt. The geological clock would stop ticking. Mountains once raised by collisions would slowly wear away under wind and rain. The Himalayas, now rising as India pushes into Asia, would cease their climb. The Rockies, the Andes, the Alps, all would crumble without renewal. Over millions of years, the jagged ranges would sink into rolling hills, then into flat plains. The planet would grow smoother, its dramatic features softened into silence. The landscapes we take for granted as eternal, the cliffs, the peaks, the volcanic islands, are only temporary sculptures of a restless interior. When the core cools, those sculptures will erode into memory. The oceans, too, would change. Without tectonics, Mid-ocean ridges would no longer generate new seafloor. Hydrothermal vents would vanish. Nutrient cycles would stall. The deep sea would become colder, darker, and poorer. Life in the oceans, already stressed by radiation from above, would find even less to sustain it from below. The connection between core and sea would break, and with it, one of the planet's most ancient partnerships. Over long enough time, Earth's surface would begin to resemble the moon's, not in appearance, but in stillness. The moon's surface has remained unchanged for billions of years, its craters preserved because nothing renews it. Earth, if it joined that stillness, would also become a fossil world. Erosion and weather would still act, but without uplift or volcanism to counter them. The surface would slowly flatten. Rivers would carve valleys, winds would sculpt deserts, glaciers would scrape plains, but all without new mountains, new crust, or new volcanic flows to balance the destruction. The result would be a planet slowly wearing itself down into featureless quiet. Even the atmosphere would feel this geological death. Volcanism has always played a role in replenishing gases, in balancing carbon and oxygen over deep time. Without it, the air would drift toward imbalance. Oxygen might decline as it is consumed by chemical reactions in rocks and not replaced by buried carbon. Carbon dioxide, too, would vanish over millennia, sequestered in rocks with no volcanic release. The air would thin, not in mass but in chemistry. Breathing would become harder, crops weaker, ecosystems more fragile. The most striking part of this geological death would be its pace. No one generation would see the full transformation. Children would still climb mountains, farmers would still till soil, oceans would still roar with waves. The changes would be too slow to notice in a single lifetime. Only over thousands of years would patterns emerge, soils less fertile, mountains lower, volcanoes extinct. It would feel like normal change until one day the realization dawned. The Earth had gone quiet. The planet had lost its breath. We can already see glimpses of this future in smaller worlds. Mars is geologically silent. Its volcanoes, like Olympus Mons, are vast but extinct. Its crust is frozen. Its tectonics ended. The moon is scarred but motionless, a fossilized record of impacts. Mercury is wrinkled from contraction, its fire long gone. These worlds remind us that geological death is not dramatic but inevitable. Heat fades, motion stops, silence arrives. Earth is different only because it is larger, able to retain heat longer, but size only delays. It does not prevent for humanity. The slow geological death of Earth would be as much a psychological loss as a physical one. We define ourselves in relation to landscapes. We climb mountains for perspective, live by fertile soils, explore volcanic islands, and measure time and the drift of continents. A geologically dead Earth would still be a home, but it would no longer be a living one. It would be a backdrop fixed in place, a museum of ancient features, stripped of the dynamism that gave rise to history itself. So what if Earth's core cooled down and the planet slipped into geological death? It would mean more than the loss of volcanoes or earthquakes. It would mean the end of motion, the end of renewal, the end of Earth as a living system. The world would not end in fire, but in stillness. Slowly, silently, the heartbeat of the planet would fade, leaving behind a surface that no longer changes, no longer breathes. A surface that is not alive but preserved. And perhaps that is the final lesson. We live in a rare window of time, an age when Earth is still alive, still restless, still fertile. We take that motion for granted, but it is temporary. Geological death is the fate of worlds. For now, though, we walk on a planet with fire still in its heart. And every earthquake, every eruption, every mountain rising is a reminder. The Earth is alive, and its life is our own. Chapter 14. The Ice World Future. If Earth's core cooled down, the consequences would not only be silence in the crust or radiation in the sky. Over deep time, the planet itself would begin to transform into something colder, something starker, without the steady pulse of inner heat, without volcanism, to recycle gases, without tectonics to refresh landscapes, the world would slip toward a different state, a frozen state. An Earth that resembles not the thriving blue marble we know, but an ice world. Heat is balance. Right now, Earth balances two fires, the fire above, from the sun, and the fire below, from its molten core. The sun provides warmth on the surface, driving weather, growing plants, sustaining food chains. The core provides protection and renewal, keeping the air thick enough, the oceans fertile enough, and the crust dynamic enough to support life. Take away the inner fire, and the balance shifts. The Earth becomes exposed to the cold reach of space. Over millions of years, its climate tips toward ice. The first steps toward this future would be subtle. As volcanism ceased, the release of carbon dioxide into the atmosphere would stop. Plants would continue drawing carbon dioxide out through photosynthesis, and weathering would continue locking it away in rocks, but no fresh supply would replace it. The atmosphere would thin in carbon, weakening the greenhouse effect. Temperatures would slowly drop. Ice ages, once cycles within Earth's climate, would deepen and lengthen. Glaciers would spread farther, snow would linger longer. What had been temporary freezes would become permanent. As the cooling continued, the oceans would respond. Without geothermal input from hydrothermal vents and seafloor spreading, the oceans would lose much of their deep circulation. Currents that once distributed warmth would weaken. The deep waters would grow colder, more stagnant. Sea ice would expand from the poles, creeping toward the equator. The once dynamic circulation of the seas would freeze into near stillness. Forests and grasslands would shrink under advancing ice. Ecosystems adapted to warmth would vanish. Life would retreat to equatorial zones, valleys shielded by mountains, or rare geothermal pockets that still held some heat. Biodiversity would plummet. The lush variety of Earth, rainforests, coral reefs, savannas, would be replaced by tundra, ice sheets, and scattered refuges of green. The atmosphere itself would thin further as carbon dioxide dwindled. With less greenhouse gas, temperatures would plunge even more. Oxygen, without tectonic recycling, would also decline slowly over time. Breathing would become harder, crops weaker, ecosystems frailer. Humans might endure with technology, greenhouses, oxygen generators, underground shelters, but the open air of Earth would feel more like the thin breath of high mountains. The sky, too, would reflect the ice world future. Without a magnetic shield, auroras would glow brighter, spread wider, filling the skies with constant luminous storms. They would be beautiful, but they would mark a world losing its atmosphere, stripped atom by atom into space. Above a frozen Earth, the heavens would dance with light, but the dance would be one of loss, not celebration. If we want to see what such a world might look like, we can look outward. Europa, a moon of Jupiter, is covered by ice. Beneath that ice is an ocean, kept liquid by tidal heating. Its surface, though, is cracked, frozen, and lifeless. Enceladus, a moon of Saturn, is also frozen, its surface gleaming white. Mars, though not fully icy today, once had water and warmth before it froze into desert. All of these bodies remind us that without internal fire, worlds drift toward cold. Earth, without its core, would follow. But the transformation would not be sudden. The Earth would not freeze in a single generation. It would creep toward this ice world state over millions of years, with each century a little colder, each ecosystem a little smaller, each ocean current a little weaker. Humanity, if still present, might adapt step by step, never fully aware of the final destination until it arrived. What would survival look like in such a frozen future? Shelters would not only be underground, but also heated, insulated against a climate that no longer cooperated. Food would be grown in controlled chambers, powered by whatever energy we could harness. Travel across the surface would mean crossing vast ice sheets, with only occasional oases of life left. Cities might cluster around geothermal remnants, rare places where heat still lingered. Civilization would survive in pockets, scattered and fragile compared to the global reach we enjoy now. For life outside human technology, survival would be even harder. Some species might adapt to the cold, hardy lichens, microbes, maybe some insects, but larger animals would dwindle. The great herds, the predators, the migratory birds, the forests and jungles, all would shrink. The surface of Earth would grow quieter, emptier. Life would persist, but in forms smaller, tougher, more hidden. And yet in this imagined ice world, there would still be beauty. The skies lit with auroras, the glaciers sparkling under faint sunlight, the silence of frozen landscapes stretching to the horizon. Earth would still turn, still circle the sun, still hold its shape, but it would no longer be the vibrant, diverse, noisy planet it once was. It would be an echo, a quieter, colder version of itself. The most profound change might not be physical but symbolic. We are used to thinking of Earth as a living world, unique among planets. But a geologically dead, frozen Earth would no longer feel alive in the same way. It would join the company of Mars, Europa, Enceladus, worlds of silence and ice. The difference would be that Earth had once been alive, once thrived, once hosted a biosphere of staggering complexity. To see it frozen would be to witness not just the fate of a planet, but the fading of a miracle. So what if Earth's core cooled down and the planet became an ice world? It would mean more than colder temperatures. It would mean the slow unraveling of cycles that kept Earth habitable. It would mean glaciers creeping where forests once grew, oceans freezing where currents once flowed, skies glowing with auroras that marked loss, not life. It would mean a planet that still turned in space, but no longer pulsed with heat. The ice world future is distant, billions of years away, but imagining it reminds us of the fragility of the present. We live in a rare balance between fire above and fire below. The sun warms us, but the Earth's core protects and renews us. Both are temporary. Both will one day fade, and in the silence of that future, Earth will still be a planet, but no longer the one we know. Chapter 15. A planet without a heartbeat. Every living thing has a rhythm, a pulse, a heartbeat. It is what tells us that life is present, that motion still flows within. For Earth, the core is its heartbeat. Invisible, inaudible, yet essential. It is the constant circulation of molten iron, the flow of heat outward, the restless churning that drives the planet's shield and its surface motion. If the Earth's core cooled down, that heartbeat would stop. And a planet without a heartbeat is not the same planet at all. We do not usually think of Earth as alive in the same sense as a creature. Yet in many ways, it behaves as though it were. The magnetic field is like a pulse, fluctuating and cycling with the currents in the outer core. The drifting of continents is like slow breathing, expansion and contraction carried out over millions of years. Volcanoes erupt like exhalations, releasing gases that refresh the sky. Earthquakes are the shudders of a restless body. All of this is powered by heat from within. Without it, the planet becomes inert, like a body that still exists but no longer moves. If the heartbeat stopped, Earth would not die instantly. It would linger, like a body kept alive by residual systems. The sun would still shine. The tides, powered by the moon, would still rise and fall. Winds would still sweep across plains, and rivers would still carve valleys. To someone standing on the surface in the early stages, life might seem unchanged, but beneath that surface, the engine would be failing. The shield would fade, the crust would stiffen, the cycles would slow. The true vitality of Earth would be gone. Even if the symptoms took millions of years to show, the most immediate sign of a lost heartbeat would be vulnerability. Without the magnetic field, the planet would be naked before the sun. Radiation would pour through the sky. Satellites would fail. Power grids would collapse. And life would feel the invisible bite of cosmic rays. The air itself would thin over time, stripped away by the solar wind. Earth would still have an atmosphere for a while, but it would no longer be permanent. It would leak into space, like breath leaving a body. Geologically, the stillness would spread. Mountains would erode without renewal. Volcanoes would fall silent. Continents would lock in place, frozen in their last configuration. The planet's face would be preserved, but no longer dynamic. It would be like looking at a photograph of Earth, beautiful but unmoving. Over millions of years, erosion would smooth that photograph into something less dramatic. Jagged peaks would soften, fertile soils would thin, and oceans would stagnate. The surface would not vanish, but it would no longer feel alive. Biologically, the consequences would ripple outward. Ecosystems depend on geological and atmospheric cycles. Volcanic ash fertilizes soil. Tectonics regulates carbon. Hydrothermal vents nourish deep-sea life. Without these cycles, life would weaken. Plants would struggle in nutrient-poor soils. Marine food chains would collapse without vent minerals. Forests and reefs would dwindle. Radiation would accelerate extinctions. Diversity would shrink until only the hardiest forms remained. A planet without a heartbeat would still host life for a time, but it would be thinner, quieter, more fragile. For humanity, survival would shift from thriving to enduring. Underground shelters, domed cities, and controlled ecosystems would become the norm. We might adapt technologically, but we would live cut off from the open world. The connection between people and planet would break. We would no longer live with Earth as a partner, but as a place we endured. A planet without a heartbeat would not inspire the same sense of home. It would feel more like a vessel, cold and mechanical, carrying us through space, but no longer sustaining us freely. Culturally, the silence of Earth would change us in ways we can only guess. For millennia, humans have drawn meaning from mountains, rivers, storms, and skies. We have built myths around volcanoes, gods around the sun, legends around earthquakes. These natural rhythms gave us stories, shaped our beliefs, defined our place in the cosmos. In a still Earth, much of that would be gone. The myths would fade into history, and future generations might know them only as tales of a time when the planet was alive. The heartbeat of Earth would no longer echo in our imagination, because it would no longer echo in reality. When we look to other worlds, we see examples of planets without heartbeats. Mars, frozen and silent. The moon still and scarred. Mercury, shrunken and wrinkled. They are beautiful in their own way, but they are not alive. They do not move, they do not shield, they do not breathe. They are bodies without pulses. If Earth's core cooled, our planet would join their ranks. It would still orbit the sun, still spin in space, still gleam with ice and rock, but it would no longer be a living world. And yet, in imagining this, we see more clearly what Earth is now. It is not just a rock orbiting a star. It is a dynamic system, a planet with an inner rhythm, a body that still beats. The earthquakes we fear, the eruptions we dread, the magnetic field we forget. All of these are signs of vitality. They are not flaws in the planet. They are proof that it is still alive. So what if Earth's core cooled down, and the planet lost its heartbeat? It would mean a world still standing, but no longer alive. A world where the air thinned, the oceans stilled, the landscapes flattened, and life diminished. A world of silence instead of motion. It would not be the end of Earth, but it would be the end of Earth as we know it. All of the heartbeat of Earth is easy to ignore, because we cannot hear it or feel it. But it is there, deep below us. A reminder that even planets live in cycles. One day, long after us, Earth's heartbeat will fade. But for now, it still beats. And every step we take on its surface is carried by that pulse, by the fire within, by the living rhythm of a planet that is not just a stage, but a partner in our existence. Chapter 16. What keeps us alive? If the Earth's core cooled down, we have seen how the consequences would ripple outward. The shield above us would falter. The ground beneath us would freeze. The oceans would stagnate. The air would thin. Life would retreat underground or vanish. Technology would flicker under solar storms. Slowly, the planet would grow quiet. But the question that lingers at the end of this thought experiment is not only what we would lose, it is what keeps us alive right now. The answer is simple yet profound: balance. The Earth is alive not only because of the sun's warmth, but because of the fire within. One gives us energy from above, the other gives us protection and renewal from below. Without the sun, we would freeze in darkness. Without the core, we would be stripped bare by radiation and left on a planet that no longer breathes. Life exists because both forces work together. We forget this balance easily. We feel the sun every day. We see its light. We measure our time by its rising and setting. But the core we do not see. We cannot touch it, cannot visit it, cannot hear its motion. It is invisible, buried beneath thousands of kilometers of rock. And yet, without it, nothing we know would exist. The continents would not drift, mountains would not rise, soils would not renew, atmospheres would not endure. The Earth would be just another silent rock, beautiful perhaps, but barren. Think of what the core gives us. It powers the magnetic field, the invisible shield that deflects the solar wind. Without it, our atmosphere would be stripped, our technology fried, our lives exposed to invisible rays. It drives tectonic motion, the slow drift of continents that builds mountains, recycles carbon, and shapes climate. Without it, the crust would lock, and Earth would grow stagnant. It fuels volcanism, renewing soils and replenishing the air. Without it, fertility would decline, and balance would fade. The core is not just a geological detail, it is the foundation of the biosphere, the hidden partner in life's story. We can see this truth in the silence of other worlds. Mars stripped of its atmosphere, its rivers dried. The moon frozen in geological time, scarred but unmoving. Mercury shrunk and wrinkled. They remind us that without inner fire, a planet is vulnerable, static, and fragile. Earth is different only because its core still beats. It is the difference between a world that sustains life and one that preserves only memory. And so, if the core cooled, we would lose more than shield, heat, and motion. We would lose the very condition of being alive on a planetary scale. The Earth would still exist, still turn, still orbit the sun, but it would no longer be a living partner. It would no longer help sustain us. It would become a vessel, cold and unchanging, carrying us through space, but offering little in return. For humanity, the challenge would be survival through ingenuity. Underground shelters, domed cities, controlled ecosystems. These would allow us to endure. Perhaps in time, we would leave Earth altogether, building homes on other planets or among the stars. But the Earth itself would never again be the same. Its generosity would be gone, its heartbeat stilled. What this thought experiment shows us is not only a possible future billions of years away, it shows us the fragility of the present. Every step we take, every breath we draw, every crop we grow, every technology we use, all depend on forces we do not control. The molten core beneath us, the sun above us, the balance between them. These are the true conditions of life. We do not own them. We inherit them for a time. It also teaches us perspective. We often see natural disasters, earthquakes, volcanoes, magnetic storms as threats, and in the moment they are. They destroy, they harm, they remind us of our smallness, but they are also signs that the Earth is alive. Each eruption, each quake, each flicker of aurora is proof that the heartbeat still beats. In a silent world, there would be no such events. There would be safety, perhaps, but only because the planet itself had died. The very chaos we fear is also the energy that sustains us. In the end, the cooling of the Earth's core is not something we will see. It is a process that will take billions of years, longer than our species is likely to endure. Long before Earth's inner fire fades completely, the sun itself will change, swelling into a red giant and reshaping the solar system. But imagining this distant fate brings a humbling awareness. We live in a rare window of time, A moment when the Earth is still alive, still vibrant, still capable of shielding and sustaining us. A moment when the core still beats and the sun still warms. So what keeps us alive? It is not only the air, the water, or the food. It is the fire we cannot see. The molten heart of Earth, churning silently, creating a shield above and motion below. It is the balance of forces, sun and core, heat from above and heat from within, that together make our world habitable. That is what sustains us, what makes this planet not just a rock but a home. And that is the lesson at the end of this journey. The core will one day cool, the heartbeat will one day stop, the planet will one day fall silent, but for now it still beats. For now, Earth is alive, and we live because of it.